Now that we've looked at those important benefits, those reasons why arguments are such significant artifacts, tools for human beings, let's go back now and look at arguments themselves in a little more detail. So all arguments are structured collections of statements. Let's start by talking about statements then. So what is a statement? A statement is an expression in language that is capable of being true or false. Now, not all meaningful expressions in a language are statements. So, for example, if I ask you, how do you get to downtown Long Beach? You don't respond to me by saying, oh, that's false. Right? Or if I were to say, look over there, you wouldn't say, ah, so true. So there are lots of meaningful expressions in languages that aren't statements. Statements are expressions in a language, the meaning of which is either an accurate depiction of the world or an inaccurate depiction of the world. They're either true or they're false. The truth or falsity of a statement is called its truth value. So, for example, Bertrand Russell is a Scottish Terrier. That's a statement. It could be true, it could be false. It is false, so its truth value is false. Bertrand Russell was a British philosopher. That's also a statement. It could be true, it could be false. It's true, so its truth value is true. Now, Perry and his co-authors don't talk about anything but these binary truth values, truth and falsity. But since all statements have truth values, they also have probabilities. So we may or may not know the truth value for any given statement. So Trump will get reelected, for example. That's a statement. It could be true, it could be false. Its truth value is as yet indeterminate. Probabilities are a way of trying to get a hold of those statements in terms of their truth values when we don't have a definitive answer about their truth values. And probabilities are just the ratios that indicate the likelihood of a statement being true. So if I say there's a 0.7 probability of it raining tomorrow, what I'm saying is I don't know if it's going to rain tomorrow for sure. Could rain, could not rain. However, 7 times out of 10, when it's been like this the day before, it will rain the next day. So it is 0.7 likely. 70% of the time, it will be true that it'll rain tomorrow. So probabilities are just estimates of truth values that we don't have definitive answers about. What about arguments then? Well, arguments are collections of statements, specifically structured collections of statements, structured in a very specific way. So we have a conclusion statement, and we have premises, reasons. Our premises are statements that express our evidence or our reasons for something. Our conclusion statement is a statement that expresses what we think follows from that evidence, what our reasons make likely or definitely true. And our argument collects those two groups of statements into groups and then relates them through an inferential claim, a claim about the relationship between those premises, those reasons, and the conclusion, the thing that's supposed to follow. And in specific, they claim a relationship about whether or not the conclusion follows and how strongly it follows. So an inferential claim will always be characterized in terms of if the premises are true, what is the outcome for the conclusion? So a deductive argument, an argument that guarantees the truth of the conclusion, it makes a very specific claim. It says, look, if the premises are true, if your reasons are good reasons, are true reasons, then your conclusion has to be true as well. It is also going to be true. The truth of the premises guarantees the truth of the conclusion. So we've got a conclusion, a statement that expresses what we think follows. We've got our premises, statements that express our reasons, and they're related to each other in terms of both their grouping and the relationship that's being asserted between the premises and the conclusion. And this relationship isn't an actual relationship. The premises don't have to be true. They don't have to be false either. But there has to be this relationship that if the premises are true, whenever the premises are true, then the conclusion. So let's take a look at the two important inferential claims that characterize deductive and inductive arguments, the two major classes of arguments. So let's draw a circle out here, and in this circle are all the statements that are highly probable, that are likely to be true given what you know. Inside that circle is another circle, a circle of the total truths, the things that are guaranteed to be true given what you know. May not be aware of their truth. You may not see that they have to be true, but they are true given what you know. What you have is the set of things that you know are true, you're aware are true, you believe are true, and I call those the reasoner's truths. So arguments then relate premises and conclusions in the following manner. The premises, ideally, are going to be part of the things that you know or believe very strongly are true. And if you're producing this argument for a consumer, you're going to try and produce an argument that has as its premises things that the consumer thinks are likely to be true, believes strongly. I know these things. The conclusion of a deductive argument is going to be one of the things that has to be true given what you know. You don't know it's true, but it has to be true given what you know. And your deductive inferential claim then is a claim about the relationship between what you believe, your reasons, and the conclusion. And the claim specifically says, if those premises are true, if the reasons are in fact true, then the conclusion also has to be true. And it's a very rigid relationship. If the premises are true, the conclusion must be, has to be, cannot fail to be true. That's the inferential claim for a deductive argument. What about an inductive argument? Well, again, you start off with things that are part of what you believe or know or have available to you, and you make a claim about something in your conclusion. In this case, your claim is that the conclusion is highly probable. So you're saying, if these things are true, if my reasons, my evidence, my truths hold, then the conclusion, this statement over here, it has to be very likely to be true as well. And that's the nature of an inductive claim. If the premises are true, the conclusion is highly likely to be true, is very probable. We'll pick up in the next module by talking about the relationship between arguments and inferences. So I'll spell out that idea that arguments create a roadmap or a model for an inference.